Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you are new to this channel, or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you'd like to support this channel, there is a super chat that runs alongside each of these shows while they're live. There's also a PayPal link in the info box below this video. Most importantly though, if you would like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel. So please share the show on social media. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now we are joined by The Plain Truth, Spurs Schemo, Sleeping Warrior, Jose Soundly Slayer Gonzalez, and Arwin. Good to have you all.
Good afternoon.
Yo, yo.
Hello, hello, hello.
What? Yeah.
So let's rattle through housekeeping. Any signs of curvature?
None.
No.
Any signs of axial rotation of the Earth-based variety?
Definitely no axial rotation.
No, no.
Stationary.
Any scientific evidence of gravity?
Nope.
No. No word salad this time, Arwin.
No.
Yeah,
Any
if you're going
evidence
to
that
do
you
that,
can have
I'm going to bring it up every time. I was going to be silent, but yeah, there are still evaluations.
I never brought it
So
up.
there you go,
right.
Jose.
I never brought it
That's
up.
what you get.
So,
Jose, stop triggering him.
if I can slip it in at the right timing, I'm sure I can do this. There we go. Any evidence that you can have a gas pressure without a container for all the people who believe in outer space?
No.
Not a serious one there.
Yeah, it is serious. There's lots of people who believe in outer space, Spurs, I assure you.
I mean, there's no serious evidence.
Yeah, but still, there are people who genuinely believe there's this region called outer space that you can travel to in tin cans and go to the lights in the sky. So, you know, and that bit of that region is a vacuum. But we've got this thing called gas pressure, right? This stuff that we're all breathing, right?
Mm-hmm.
Well, that needs to press on something. But according to the heliocentric zealots, rather than actually pressing on something, it's pressing on a lower pressure known as a vacuum that it should really disperse into by way of entropy. But there we go.
Gravity. See? Gravity is all they need to explain being held into place.
Yeah,
Without
we get that a
gravity.
lot. You know what we say to that though?
no,
We
not
say,
at all.
no problem, show us evidence of gravity maintaining gas pressure without a container. And we get a load of, we normally get annoyed faces and anger at that point because there's no demonstration
They
of
need
gravity.
space time to bend.
Whether if you can physically prove that or not, which is very impossible to do so, even theoretically it can't work. I've explained it many times. Gravity should be a stable force disequilibrium pushing against matter that's just not enough to oppose the natural force of entropy of matter to expand in the entire container of this supposed universe of vacuum, which is super wide. So it'll all be ripped in there, as no gravity can withhold that, can stop that, even in their own theoretical model.
Is this payback because Jose said something?
No, this is just the truth.
Really?
Okay.
Yeah,
The truth according to Arwin, right?
yeah.
I'm
Even
quiet over here.
supposedly it doesn't work. That's what I'm saying.
Arwin, but in
to
the last show
understand.
in the housekeeping, you had a lot of word salad too. So you let this one go, man.
Mad from the chat says, ask them, how does gravity affect wind?
Oh,
There is no wind.
There's definitely wind. That bit, I'm not gonna let that slide.
just
Okay, well, if that's all stumped you,
assume
any
gravity
evidence of
for a
a...
moment, it affects wind in that the pressures going around will be thicker near the ground as above, and that's basically it. It's more pressure lower down. But yeah, you can work that out with the relative buoyancy just as fine.
Billy, shut up.
You killed the flow, Riley.
Tilly's killing the flow.
Yeah, blame the dog.
So, Arwen, do you have anything better than it can work? So, you know, I mean, if the ball earthers can't explain it, but you're saying that it's possible. Well, actually, you gave an answer. You said that you think the plane has turned around or something, yes?
Well, you don't know. That's the whole deal.
But so the point is, you're saying that it's not possible to see that phenomena in a straight line. The sun rise, the sun set, sorry, and then the sun rise out of the same horizon. Yeah, you're saying what we're seeing is not possible on a globe.
Well, I'm kind of surprised to see a sun setting on the left, which should be supposedly the north. So I'm kind of surprised to see it set there at all.
That's why it
doesn't make any damn sense.
That's why.
So there's something weird with the orientation. I don't think the flight path
no. This is the thing you see. This is the thing you see, Arwen. This is why I didn't get bogged down with the globers on this east-west flight, the spinning of the. You know, we have to go by what we see, and we see the sun. What we see a map of the globe or the flat Earth. We see the tracking. You know, you can track that flight. We see the sun, like we actually see the sun. You know, it's not an illusion. We see it. We see it go down. You guys say it's going down, set. And then we see a continuous path all the way. Doesn't appear to turn, but if, you know, again, if you're saying that's a possibility. But on a ball, the main thing is, Arwen, on a ball, this wouldn't work.
Hey, Wiggles.
Is what you're saying.
How you doing?
Oh, hello.
Good to have you.
Hello, Wiggles. Hello.
Hello.
Hello, good to have you.
Oh, good. Oh, good to be here.
Can you hear me, Wiggles?
Yes, I can hear you, gatekeepers.
I got to change that. Yeah. No, that's people are gatekeeping the flat Earth. The ball earthers, namely.
Do you understand what gatekeeper means? Do you want to talk me through what you understand gatekeeper to mean?
Yeah, I think isn't gatekeeping when you say that only you deserve to have some sort of title or something like that?
No.
No. Gatekeeper, you control the narrative. We're not controlling the narrative. We're asking you guys for evidence. That's not gatekeeping.
Oh, okay, yeah. Evidence is good. Well, I know you said there's no evidence for like a curve, but I think there is evidence for a curve.
Wiggles, you're a globe earther. Yeah, you believe in the ball, right?
Yes, that's right.
So I'm going to show my screen because I've been trying to get an answer. I've had various answers. Let's see how you want. So you see my screen?
Yeah.
Yes,
Okay, so we have a flight from, let's go back to the beginning. We have a flight from JFK Airport non-stop all the way to Moscow. We're looking out of the left window, yes. We see the sun. As you know, as we see the sun, it's going down. It looks like it's going down. Let's go forward. So what I want to know is basically, as the sun sets now at this moment, would the sun appear back on this horizon out of this window, or would we expect to see it? Would we have to go to the other side to see the sun, in your mind? Let's watch the video so we can see what happens first. So I've just sped it up so we can just fly through it. Yeah. So you see the sun, it appears to go down. It's going down. He's tracking. He's along that horizon still. So we know he hasn't turned anywhere because we still see the lights, right? So now the sun is rising again. How do we explain the sun reappearing along this same horizon?
Well,
We're now in Europe.
yeah, it looks like the sun there is rising towards like the bow part of the plane.
Along this horizon.
Yeah, but we don't. Yeah, but we can't really. I can't really see where the sun is, and that's.
Yeah, because he's kind of in front of it, yeah? So he's
Yep.
kind of in front. He's looking back. The sun, it goes down. Yeah? You agree it goes down?
Yeah, it goes down.
Yeah, it's gone, disappeared. So the sun is back there, just around here somewhere, yeah? You see the light of the sun. So we know we haven't turned. Or what's your explanation so far? Do you think the plane is turning, or...
Well, the sun rises in the east and sets in the west.
No, but I'm asking what we see here. Not what you know, what we see. What do we see here?
Well,
And
the sun is not.
I try not to pay attention to this map as well. Forget this map, this flat Earth map. Just look at, what we see. We see the sun go down. We're looking out of the left window. Yes.
Mm-hmm.
Okay. So the sun goes down on a ball. It should be going down, 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 all the way around the globe. Yes, and does it not come back up the other side? I'm asking you.
No, it does. It doesn't come up like on 180 degrees away from where you were looking.
What happens is what I'm asking you.
Like the geometry of it, I guess, is a bit complicated, but it's
Yeah, no shit, Sherlock.
but if you're looking on the equator, I think like it would come from the other side. But if you're up farther north, then the sun, like, it kind of moves over a bit where it rises. That's my best explanation.
All right, look, let's have a
Does
look.
it go to the north ever? Like
Yeah, the sun will rise a bit more north on your azimuth.
what? No, that doesn't make any sense. It should be rising in the south, like on both models.
Was
Sun
that just
never
that might have
rises
just been
or
a
sets
hold
in
on,
the
hold
north.
on, Owen. I think that was just do you mean set? I'm sure you just mean set, right?
And rise. They rise and set always in
Not
the
not
southern
you, Wiggles.
half.
J Money.
What you're looking at.
J Money. Woo.
It's about sun trajectory.
What's the bloody line?
Knowledge Scavenger did a hangout about it. The sun's trajectory always
Right,
starts.
so look, Wiggles, are you with me?
Southern-
Still here?
Yeah, I'm here.
Your view.
Okay. I don't know how I'm going to do this. So let me slow this down a little bit.
Let me just remind folk of who Wiggles is. Wiggles is the guy that basically, when we asked him to put the maths on, allowing for perspective, he quickly removed it off screen. Do you remember, Nathan? That was Wiggles, wasn't it?
Yeah,
Oh, I can
that's
put that
pretty
back up if you want to go back into that.
Oh, yeah, we could finish that one off. Yeah, definitely, Nathan. What do you
good.
reckon?
Don't hijack Spurs' point.
No, we won't do. We'll come back to it.
Yeah, and after that, he said he got proof of a curve, so I want to see that.
But
too.
hold on here. Are you sure it didn't went from Moscow to JFK? Because that would make a whole lot more sense.
No, it went from America to Moscow.
That this
So
just
look,
doesn't
now
make
look,
any
Wiggles,
damn sense.
Wiggles, can you explain to me, right? He sees the sun. He's leaving America. He's in America. The sun's over America. And which way will the sun go? Would it go that way or this way? To the left or to the right?
Well, it's the sun. It's the Earth that's spinning that causes the sunrise and sunset.
Okay, so that's fine. But so that's what I'm asking. That makes it worse for you because if the Earth is just turning in that same fashion, it has to come up the other side.
Yeah, but where you're standing up, like on the top of, like, closer to the North Pole, like, you're kind of looking at an angle, so the sun is going to be more north on your horizon.
No, again, when the sun has set. Okay, let's get to the part where the sun has set. Just
Right.
here.
Spurs, you need to
Where are you saying the sun is?
Spurs, use the word antipode.
Yeah. Oh, yeah. So, but can you explain, Wiggles, where the sun you think now is setting? Where on the ball for the plane? Is it just here? Where are they seeing? Where is it going behind this? This is the horizon. Yeah, this line.
No.
What was the date when they did this? Was it during summer? Has it been recently? When was this?
Your horizon is like a little circle around where you're
Massive
where you're
circle.
currently standing, or
A massive circle, a huge ball.
Hold on. Can you just Spurs and Wiggles talk?
Yeah,
Yeah.
I'm just trying to find. Well, I don't mind if people want to jump in, whatnot, but I just want to find out.
I do. Just let it be Spurs and Wiggles.
The plane
Sorry,
is
Spurs.
here, going across this water. I mean, because suppose it goes around in a bow like that. That's fine. But either way, it's going that way, Wiggles, or is it not? Which way is the sun going? Is it going with the plane? Is it going away from the plane? What's happening on your board?
the sun is not on the ball. Like the sun is not really moving at all.
Okay.
Because it's the Earth that spins that causes sunrise and sunset.
Okay, so the sun is stationary where my mouse is, yeah?
Yeah.
For example, it stays there.
Yeah,
So
93 million
the Earth
miles
is
away.
turning. As the Earth turns that way, goes with
Yeah.
the plane. Yeah, goes that way. Okay. So the sun stays there. So again, how is the sun not coming up directly underneath it? How do we get the sunset coming back up? So it goes down here and then back up over here. Rises here. How does it rise here is what I'm asking you.
Well, the sun is not moving.
Well, again, if it's here where this arrow is,
Yeah.
and the Earth is turning like so.
Well, you got to be careful, right? Because you got to be careful to scale this. The sun is like really far away from the Earth.
It looks it, but go on.
Yeah. So as the Earth spins, right? Like just think of the sun as in line with the equator, really far away. Like you've seen like the models of the solar system.
Okay, go on.
So yeah, so as the Earth spins, like you're gonna see the sun coming up on the north side of the plane.
Are you saying it can be sunny in a Moscow and America at the same time?
Yes, it looks like it. Yeah. Well, it is on that. It is on that picture that we're looking at right now. It's the Moscow part of the globe is illuminated, and the JFK part of the globe is illuminated at the same time.
So you would have sunset at the same horizon as sunrise.
I'm not sure what your question is.
So you're looking out of the window this way. You're saying the sun goes down behind this horizon.
No, the sun stays where it is. The sun is really far away, and it stays where it is.
You've said that 4 times, Wiggles, right? That doesn't respond to his questions. So the Earth turns, and the sun stays where it is. Okay, we'll work just in the solar system model. Hi, Julian, can you hear us?
Yep.
Good to have you. So if it turns to move the sun's relative position in your worldview, then it would presumably, as Spurs has said about 5 times, come up the other side. But that would put it on the opposite side of the plane as the Earth turns.
No, it would put it like roughly on the north side of the plane there, northwest, the like sort of bow and left side.
But that's the opposite of what Spurs is asserting, so maybe you can explain why.
I don't know, I might not have a good explanation of why that happens, because I haven't really thought about this beforehand, so...
Fair enough.
Okay, that's fair enough. No, just wanted to get a few opinions. Some people, like I say, think the plane has turned, or they have different various ideas. So, yeah, I don't think you can explain it. It's just as baffling to me as it is to you, Wiggles. So, yeah, we'll just leave it at that then for now.
Okay.
Unless anyone else has anything to say on it.
I don't think Wiggles knows what he's talking about.
Well, the sun is 330,000 times greater than the Earth's mass, and accounts 98% of the total. Let's see what it says. Total area of the account of total mass of the solar system. So I'm not sure why we have a focal ray or focal light if it's 330,000 times greater than the mass of the Earth. So, my gosh. I don't know how that works.
What did you say? As a what? 330 times greater than the Earth?
The mass of the Earth.
And
330. My Siri.
Oh, your theory. So you just made that up on the spot, right?
Hey Siri, how big is the sun?
Sun has an area of 2,351,362,145,523 square miles.
Oh my God.
Do you want to ask Siri what evidence she's got to support that assertion?
I don't think.
Because I bet I can know what the answer is going to be. Sorry, I don't understand that question.
Yes, I've gotten that before too.
No, mass of the Earth is established by Cavendish.
Oh, I thought he proved gravity.
No, he weighed the Earth. That's the primary objective of that apparatus. Is to weigh
Was that a
the
scientific experiment, Nathan?
No, don't be stupid. It's ridiculous.
So why
Two balls in a shed cannot give you the weight of the Earth, but that's what they have. That's what they say. It's just preposterous, but that's what they say.
Why
I was
Earth,
confused, if I might ask. Like you said, there's no evidence for gravity. We're kind of all stuck to the Earth right now. I think that's the evidence for gravity.
Really?
No, that's evidence
Yeah,
of
like
relative
down
density.
to my own weight.
That's relative
What's
density.
that?
Yeah, my own weight relative to the air that I'm studying. You understand how relative density works, right?
There's a force keeping you in your chair right now.
What force is that?
Gravity.
How are you going to prove that there's a force there?
Because, well, there is, isn't there? Like, aren't you not floating away right now?
Sorry,
No, but
you are more dense than the air. Hold on, let's just get it one step at a time. Would you concede that you are more dense than the air, therefore you pass through it? That's not a force, that's your density being greater than the medium that you're in.
Yeah.
Right, there's no force there then, you're just of greater density. It is
There needs
relative
to-
density.
If you imagine, like I don't know, an astronaut in the International Space Station where there's, like, no gravity, he's denser than the air, but there's no net force acting on him, so he doesn't move through the air.
Yeah, but that's the point. You have to imagine that, right? You can't do that real world. It's a make-believe story.
Well, it's consistent.
So what?
Alright.
That doesn't make it true.
I mean,
Well,
if I assert
You
that-
need a force to act on. You need a force to keep you in your chair, right? You need a force to keep you stuck to the surface of the Earth.
Right. No, hold
How do you know
on.
that?
Hold on real quick. That is based upon a presupposition. So why do you need a force to keep you in a chair?
Because otherwise you'll just float away.
Why?
Well, because
How do you
there
know
would be
that?
no force.
How
to
could
keep
you
in-
prove that? How could you
Yeah,
prove that?
right. No. Hold on, Arwen. Hold on.
Happen?
Right. That's the whole thing. You are presupposing a reality that doesn't exist. Why are you saying we would float away?
Well, because that's the theory. That's Newton's theory of, like, forces.
Okay, but based on
Claims
what?
no proof.
Based on observation. That's,
Observation of what?
that
Well,
this
you
is
just
what
said
happens.
it's a theory. You just said it's a theory, so it's not. It hasn't been observed. It's just a theory.
Yeah. No one's
how
ever
can you
observed
possibly
anything
know that?
floating away on its own without a force. So there's no observation of this theory.
You need a force to make something move.
Well, people
Right.
have observed it, but you won't believe their findings.
Yeah, like, force is a measurable, like, dimension. Like, it's
No,
a
hold on a
measurable
second.
phenomenon.
Force is an interaction.
Other things floating.
Hold on. Who threw that out? Somebody said it has been observed. So we have an observed phenomena. Who said that?
Yes.
Is that Julian?
Yep.
Pleasure to have you, Julian. So what's been observed exactly?
Well, that things move and keep moving if there's no force put on them.
So are you saying this is a phenomena?
Well, they've had things float in the ISS, but
How do you know?
unfortunately, you don't believe that. So
Well,
that
I mean, we can
discount
explain
all
why,
that evidence that
but there's
the
a
human
reason
race
why.
is.
Hold on, you're
intellect.
telling the audience you don't believe that. It's not that I don't believe that. I understand fundamentally that we have gas pressure. Would you agree?
Gases can be at pressure, yes.
Well,
Sorry,
the one that we breathe.
we are currently breathing a gas that is pressurized. Would you agree?
Yes.
Right. So that would require something to press on. Would you agree?
Yes.
Right. Well, where you claim the ISS is, that medium is a considerably lower pressure system.
Mm-hmm.
Well, entropy would dictate that. Shout out to Freeman McCoy for the super chat. Entropy would dictate that the pressure, when next to a vacuum, it's got nothing to press on. In fact, it would disperse into that vacuum where you think the ISS is.
Why would it do that?
Because that's the law of entropy. If it's got nothing to
Yeah,
press
but the law
upon...
of entropy isn't greater than the law
I
of
was in the
gravity.
middle of giving you an answer. So if it's got nothing to press on, but instead a lower pressure system, it would, whilst trying to press on it, disperse into it.
Well, no, it doesn't work like that.
Yeah, it does. Well,
Pressure,
no problem. If it doesn't work like that, please can you give me a demonstration of gas pressure being maintained without something to press upon?
Yes, you're in it.
Sorry, that's an assertion of your religious belief that we live in a gas pressurized environment that doesn't have a container. I'm asking you to demonstrate it as opposed to assert your religious belief about Earth. Demonstrate it. Don't just say I'm living in Earth and that's in the space. That's the bit we're trying to prove. Don't just assert it.
Well, does the gas pressure change as you go higher in altitude?
No problem. Anthony, no problem. So we have a pressure gradient. No problem. Demonstrate a gas pressure gradient without a container. The antecedent for a gas pressure gradient is gas pressure. To have a gradient, you must have gas pressure. And to have gas pressure, you must have a container. So it really doesn't address how we have gas pressure without a container by asserting we have a gradient. That doesn't address the problem.
But the gas pressure that you're experiencing, in my opinion, is brought on by the fact that gravity is...
Isn't that where we started? Sorry, so we're back to gravity then. That's what I asked you. You said that we observed this. We're getting ever closer to us asserting the scientific validity of this thing you claim we see.
But we have people in space that...
Yeah, space is a medium that is proven by gravity maintaining a gas pressure gradient. Even though you can't demonstrate this to me, so we're still on gravity. We're not going to go into this circle jerk of you saying some place I can't go is proven by something I can't experience. So we're going to prove one or other of them. Stop talking! We're either going to prove one or other of them. Either that you can have this medium, a vacuum, next to the pressure that we all know and love, or the gravity you claim can maintain this pressure without a barrier. So one or other is going to get demonstrated by you. You're not just going to continually assert in a circle jerk that one proves the other. So which one do you want to prove? Gas pressure maintained without a container or scientific evidence of gravity? Pick.
Tumbleweed.
Which do you want to demonstrate, Julian? Your religious faith in gravity or your religious faith in a vacuum that is next to gas pressure? Which one do you think you can demonstrate as opposed to using the other one to back your religious faith in it?
Well, that's the scientific method. You make multiple observations.
Let's go through the scientific method. Which one do you want to go through the scientific method with? Vacuum of space or gravity? Do you want to pick one? Rather than circle jerking us back and forth between the two like one proves the other. Which one do you want to prove scientifically?
Any evidence that has been gathered, you instantly dismiss it because you can't see it for yourself.
We're not instantly dismissing anything. We're asking you to prove one or other, not circle jerk between the two. I've said it twice. So do you want to pick one and we'll go through the scientific validity for it or not?
Well, let's go through the scientific validity that the air is kept on the Earth by gravity.
That's intermingling both. So you want to prove gravity can maintain gas pressure without a container. No problem. Let's see your demonstration of exactly what you've just said. Gravity maintaining gas pressure without a container. Let's see a demonstration of that.
Okay. Well,
excellent.
You just got to open the door and look outside.
That's your religious belief in the world you live in. I've said that twice also. So you are just going to assert your religious belief again? Not your religious faith about the world, Julian. An actual demonstration, possibly adherence to the scientific method, like you just asserted, is opening my door and believing what you've just told me about what the world is scientific. No, Julian, is the answer. So are we going to get some science or just your religious dogma?
Well, I can't prove it because
So shut up about it then!
I don't have...
Shut up! If you can't prove it, why are you asserting it here, religious zealot? So something you can't prove, you simply believe in, you're asserting. So you're a religious zealot. You're a Jehovah's Witness knocking on our door, telling us what to believe in, correct?
No.
You just said you can't prove it. So you only believe in this shit, Julian. You can't prove that we have a gas pressure without a container. You can't prove that we've got gravity, but you will continually circle jerk between the two, like one proves the other. This is your religious faith, Julian. That's why you've asserted it without any evidence. You just believe in it.
But we know that pressure changes.
No, we don't! We don't know that it's capable of having a pressure gradient next to a vacuum. There is a thing called entropy.
He's got a point, Julian.
So, Julian, I'm asking you a different question. Why, when you have no evidence of this, have you come here to assert it, like a Jehovah's Witness knocking on our door? You said we observed this. That's when I started this conversation, Julian. You said we observe gravity. No, it's just your religious belief, Julian. Hello? Why did you assert your religious belief in this stuff to us?
But there's no container.
We have a gas pressure though, right?
Hold on, Anthony. What do you mean there is no container? The necessary antecedent for gas pressure is a container. If you are to assert otherwise, I've asked 3 times for a demonstration of said gas pressure being maintained without a container. And you said open your door and just believe my religious belief.
Well, the religious entity that you claim is NASA has sent probes to Saturn. Saturn is a gas giant. They have sent probes into that gas. It didn't hit a container, but you don't believe any of that because you don't believe NASA.
What evidence have you got that they've sent a probe to NASA, to Saturn?
Why are we going? Why are we leaving the Earth?
Yeah, that's a good question. Why are we leaving the Earth? So we're now leaving the realms of things we understand and know, gas pressure being one of them. And we're back into the realm of a vacuum of space with gas giant lights in the sky in the vacuum of space. So even though you can't prove we can have a gas next to a vacuum, you're still going to assert your religious belief in that very medium and use that to prove that we can have gas pressure without a container. That's what you're going to say. NASA's lying to you. What they say is outer space defies the second law of thermodynamics. That's our point. Why would you now assert that some bloody light in the sky is a gas giant because NASA assert it?
Because I've seen it.
Oh, so you've been to the space realm that's a vacuum?
No, I've seen Saturn.
A light in the sky, so have I. And is it a gas giant verified by you in a vacuum of space, verified by you, or is it the same as I've looked at through my telescope, a light up above me?
It's not a light, no. It's a definable shape, discernible shape.
It's a light.
No, it's a as far as I can tell, it's a round object. Rotating.
Oh, that's fascinating. Does that make it a gas giant in a vacuum of space?
Well, due to the probes and things that NASA have sent there, it would...
Sent where? Into the vacuum of space?
Yeah.
I've just explained this. This is going to be the 4th time. You can't have gas pressure without a container. NASA assert that we have gas pressure and simultaneously a vacuum of space right next to it. That would defy the second law of thermodynamics. You can't have the outer space where this stuff resides. If we had a vacuum, our gas pressure that we are breathing would instantaneously disperse into space.
No,
so Nathan, do you think there's like a giant container holding all the air in?
I have no idea what's holding all the air in. You assert we've got a vacuum of space. I don't know what's up there. I'm not making any assertions about what's up in the sky. This Muppet's telling me that the light he sees through his telescope is a gas giant in a vacuum of space. Have I said what's up there? Have I made any claims about what the sky is? Wiggles.
I don't think you have.
No, right. So you dickheads think that that's a vacuum, right? So let's rip your claim apart, not worry about what I'm claiming. You say space is a vacuum. I say, well, that's a bit odd because we've got gas pressure. And the necessary antecedent would be a container. But according to NASA, the guy he's referring to defend this objection, they're saying there's no barrier. We're travelling out with the probes. Well, that doesn't conform with my original objection, Julian. If there's no barrier and the probes can go out into the lights in the sky, then how are we breathing?
Because the air's being held to the Earth by the density, the mass of Earth. And
you mean gravity? The other shit that you can't prove and just believe in. So we are very quickly back to you asserting your religious belief. You can't prove that space is there, so you're going to prove gravity's there now, are you?
Just because I can't prove it doesn't mean that it's not there.
You don't have to. You don't have to.
I tried.
Hold on, Arwin. You don't have to. You can go to any source you choose. Any. The whole of the Western world is taught that we live on a sphere. You as an individual, doesn't matter what you think, I want you to prove it based on what you can obtain from the current rhetoric, which is 2,000 years of assertion that we live on a spinning sphere. So, prove it.
Well, where does it say that pressure needs to be in a container to have pressure?
It's the necessary antecedent. Let me say it again. What is it, the 5th time? I can give you demonstration after demonstration of gas pressure being maintained with a container. It's the necessary antecedent. Now, if you're to assert otherwise, then you need to show me gas pressure maintained without a container. Not say, where does it say that? It's the necessary antecedent. Without the container, there is no pressure. Go ask a high school physics teacher.
I think what Julian is saying is like if you pick up a baseball and you drop the baseball
That's not what he's saying, Wiggles. Shut the hell up. No, that's not what he said. Those words didn't cross his lips. Why are you talking? I was talking to Julian. He mentioned nothing of baseballs. That's not what he's saying. Shut up. So, Julian, are we going to go round in circles forever with you asserting one religious faith after the next?
No, but pressure's just the force of one substance on another substance. The pressure that we're under is the pressure of the air above us.
Oh, right. And what's above that? A lower pressure system that the pressure of the gas at the top would try and press upon but actually disperse into?
No, at a certain distance, yes, the air would drift off into space after it gets past.
Well, no, that wouldn't just drift off. No, let's not dilute that down. It doesn't just casually drift off. If you have a vacuum next to gas pressure, it instantaneously disperses into the vacuum. Would you like a guy from MIT to explain it to you? I can dig that out if you would like. Yeah, gas pressure next to a vacuum doesn't casually drift off into space. It instantaneously disperses into the vacuum and fills whatever space it can. So why would you assert such nonsense that it drifts off into space slowly?
Place. So it doesn't instantly fill the entirety of space with the with the air that leaves.
It does, mate.
It doesn't. Because
it does. We need a demonstration, Nathan.
It doesn't because
it does, mate. Right?
Stuff has got to.
Hold on. No, don't run for him. Let's hear it. He's trying to give an explanation. Let's hear it.
Unless you're talking about, quantum theory, the atoms of the air molecules have to travel to locations. They don't instantly fill.
Nathan, we need
space.
some
Anthony, just let him talk.
The pressure that we're experiencing is the pressure exerted on us by the air above it. That air is being pulled down to the planet by gravity. I'm unable to provide you with a proof of gravity, but that would be the most reasonable explanation. It is because if it was in a container, the air would disperse evenly in that container.
We need some evidence, Nathan.
MIT OpenCourseWare at ocw.mit.edu.
All right, let's try another pretty simple process. Let's just take a gas in some volume, V, and over here is going to be vacuum of equal volume, and we're going to remove the barrier. You know what's going to happen spontaneously, right? The gas is going to fill the available volume once it becomes available.
So the gas will fill the available volume once it becomes available. We have a gas, yeah? This is us, breathing gas. We definitely know this bit exists. This bit here is asserted to be space, and according to an MIT professor, if there is no barrier, the gas will fill the available volume. Did you hear him, Julian, or does it need to be repeated to you?
I heard what he said.
Right, so we have gas pressure, don't we, Julian?
We have gas under pressure, yeah.
And space is asserted to be a vacuum?
Correct.
So we have the two things that are here, gas and vacuum. In his example, with a barrier. So, Julian, you've said NASA sends probes out, right? So no barrier in the way of those probes, correct, Julian?
Correct.
Right, well, according to this guy, the gas that we have can't exist next to the vacuum. It would fill the available volume.
In the example he's showing, yes.
Yes, gas. That's us here on Earth with gas that we all know and love. That's the vacuum that you say is space that can't be proven, you've never visited, and is asserted by NASA. And according to MIT, those two circumstances would end in this not being here anymore, but filling the vacuum. So we're gas pressure, and space is a vacuum according to you idiots. That's not compliant. The gas that we're breathing would fill the available volume. And do you know what that volume is? An infinite mass of space. So our gas pressure is not going to last very long. It will fill that space immediately, instantaneously. It won't drift off slowly like you asserted, Julian.
Well, can I hear from whether he agrees or disagrees with this example? I mean, because he was saying, well, this, yeah, so obviously in his head or in his mind, he sees, you know, something different. So what is that difference, Julian?
Sorry, I just need to go back to this, what's on the blackboard here. What's on the blackboard is an example of a gas and a vacuum in two containers in an experiment with no additional external factors being evident. There is no gravity on the diagram that he's shown there.
Mm-hmm.
So yes, if you had a
what kind of
Sorry,
diagram?
can you stop interrupting him?
Gravity doesn't
Stop
substitute
interrupting him.
for
He's in the middle of a
container.
sentence.
if you had a gas in a bottle, for example, and you had an empty bottle that was at that had been evacuated of air, so it was close as possible to a vacuum, and you connected the gas bottle with the vacuum bottle, and you released one into the other, then it would exhibit the example on the blackboard. Yes, the gas would move into the vacuum, and they would equalize. Right. But that isn't what is happening on Earth, unfortunately, because there are other factors involved, which is gravity.
What factors would they be?
Oh, right. No, gravity doesn't substitute for a container.
Arwen, what factors might they be?
So the example that you're showing here isn't relevant because it's not showing what is happening on Earth.
Sorry, Earth has gas pressure. This fantasy
hold on,
region...
Nathan, hold on, sorry, Nathan. So are you saying, Julian, even in this experiment that we're looking at now, gravity is not applied? So we can remove gravity from what this guy is explaining? He's not
explaining it with gravity. He's just saying that gas moves from...
hold on, so you're saying there is such a situation where gravity is not like this now, the gas and the vacuum, gravity plays no part in what he's talking about?
At this moment in time, I don't know this video, so I would assume yes, because he's just showing me an example of a container with gas in and a container with a vacuum, and he's explaining that when you take the middle away, they equalize. Yes.
So gravity is not involved.
That's correct.
How is that possible?
Well, it's just an example on a blackboard. It's a theoretical explanation of the process.
Forget about space. You'll say this is not to do with space, but even on Earth now, with this experiment or demonstration, how is gravity not involved?
How is gravity not involved on the example that he's put on the blackboard? Sorry.
Yeah, in any example, given that gravity exists according to your religious viewpoint, I mean, why wouldn't he assert your religious viewpoint when demonstrating the simple nature of a vacuum and the fact that gas pressure would try to press on something, and when it's not there to press on, it would go into the vacuum? And Earth has gas pressure trying to press on something that isn't there. There's a vacuum, but apparently that's not going to disperse because apparently gravity, something that's not scientifically valid or proven in any way, shape or form, is going to keep it here.
Well, the problem is with proving gravity.
Saying that gravity is removed from this one, but the other one applies gravity. And how any ball earther, I think, would disagree and say gravity is what is causing what he's talking about.
No, it's not. It's
not.
It's not. If you were in a theoretical universe.
No, I like that line. Let's go with that. If you were in a theoretical universe, go on.
If you were in a theoretical universe where all that exists.
Hold on, Anthony. Is he saying this is density and buoyancy then? Not gravity. What he's talking about.
No, what I'm talking about is if these objects, this gas container and this vacuum container, were in a theoretical universe where no other things could act on it, when you join the two tanks together, the gas would move to half fill the vacuum. So they would reach an equilibrium where the distribution of gas would be half the amount if the two containers are the same size.
With or without gravity.
Hold on, why didn't he say that then? Hold on. If is that a necessary disclaimer? Why didn't this MIT professor disclaim that?
Because I don't know what the clip is. I don't know the reference of what he's talking about.
He's
talking about
entropy.
How gas travels.
I'll tell you. He's explaining entropy.
He's explaining entropy.
Correct.
Right.
Yeah, if I might interject, I have an example of a gas staying in a container without, like gas maintaining its pressure without a container.
Oh, really?
Okay,
yes.
Nice. Let's have a look.
I sent a link in the chat. I don't know if you can see it.
No, you have to just present it. Just right-click over your Hangout screen, bring it up, present your screen. Let's have a little goosey.
Screen share, okay.
What's the timestamp, Wiggles?
It's the video again with the heavy gas and the...
I don't know. I don't know if you can hear. Well, you don't need to hear anyway. But
see.
Okay, I know the video. I'll get a copyright strike if I play it, unfortunately. So what you've got is a gas that's sulfur hexafluoride, which is considerably more dense than the air.
Seems to be in a container, Nathan.
Say again?
Seems to be in a container.
Yeah, it's also in a container. Wiggles.
Why do they have the fish tank there? What's the purpose of that?
It needs a container.
to hold the gas, right? Because the gas is...
It's a container, right? A container.
Wiggles, it's being contained, no?
Yeah, but there's no top on the container.
Sorry. Yeah.
Okay,
there is a top on... Hold on. There is a top on the container. When they pump the gas in, they have to increase the pressure of the gas. And in order to stop it escaping, they have to close the container. However, the gas is of a considerably higher density than the air it's in, so it settles at the bottom of its container.
Yeah, but there's no... It's not a fully enclosed container.
I'll say it again. When it's at higher pressure, they pump it into the container. bearing in mind we're asking for gas pressure without a container. So they pump it into the container and seal the container with a lid because they are pumping it in at a higher pressure. When they have pumped it in and it's no longer at a higher pressure, it is only at a higher relative density. It sinks to the bottom of its container. Wiggles.
Okay, so if you want to go that way, then air is denser than vacuum, so air falls down.
Right.
No.
Oh, let's not
air
go down the
is
route. Density is
no.
only
Hold
relative to
on.
density
So
only.
air's pushing out, right? You have this value, Wiggles. PSI. Do you know what PSI stands for?
Yeah, pounds per square inch.
What do you think the square inch bit is?
Area.
An area of what?
The surface.
So a surface to press on to give you the pressure. But you think that it's not going to press upon the vacuum, it's going to fall back down with its own weight as that gas tries to push and give itself a PSI value. It's not pressing on a surface, as you put it. It's pressing on a much lower pressure system. Right, Wiggles?
I'm not sure you're making sense, sorry.
No, that's you're being stupid. It's trying to press on something to give it a PSI. But in your world, you just said it's just falling down with its own weight. No, Wiggles. It presses in equal directions, trying to give itself a PSI value on the surface it presses on. So what's that surface on Earth according to globetards? Oh, it's not a surface. It's a lower pressure system. Well, can you press on a lower pressure system? No. No, it would disperse into it, Wiggles. Because it's not a surface.
I don't know if you're making sense.
Yeah, that's the second time you've said that, Dumbo. Do I need to explain it a third time, retard? Shall I start calling you a retard? Because that's the second time I've explained it. You took us through what it needs to get a PSI value, didn't you, Wiggles? A surface to press on. So does it have that? Is there a barrier up in the sky to press upon? Or is it a barrierless system with a lower pressure system? Something that it can't press on and give it a PSI value. A pressure. Hello, Wiggles. You going to say I'm not making any sense again, Dumbo?
No, like that in that sulfur, that fish tank of sulfur hexafluoride.
Oh, the gas you showed us in a container. Yeah, what about it?
Yeah, it doesn't have a top. Just
yeah, it does. Oh, right, Dumbo. When they pumped it in under higher pressure, it had a lid, didn't it, Wiggles? Are you going to lie and say there was no lid involved? Hello? There was a lid, wasn't there, Wiggles?
Hey, Nathan,
I got a better point. I got, even serious. Like, you think that aquarium set up with that specific gas, you think that will work in a vacuum chamber? You think that'll stay in that aquarium?
No, in a vacuum chamber, the gas is going to probably... Well, actually, I don't know.
Why do you think that is? Why
there you go.
Nice one, Arwin.
I don't know. That'd be interesting to try.
Yeah. I'm sure that gas would hang around next to a vacuum.
Because gravity's pulling to the bottom of the fish tank. It wouldn't magically raise above the fish tank. Jesus. This is like simple stuff, guys.
Oh, yeah, in the vacuum chamber, yeah.
Put it in a quotes universe that didn't have any other factors upon it, then it would disperse into the vacuum. Yes, it would eventually. Well, technically,
you're making our point for us.
Technically
Julian.
not.
Thank
no,
you.
technically not, because it wouldn't.
Oh, technically not. So it would, but now it wouldn't. When I said, "Well, you're making a point for us."
Let me have a think.
Yeah, it would disperse. That's called entropy. Check it out. MIT give a good lecture on entropy. You can check it out on my channel. He explains that if you have a gas next to a vacuum, it disperses instantaneously into it. It's amazing.
Sure.
You know your sulfur hexafluoride that you had in the container that didn't have a lid on it?
Yeah.
If you were to take that carefully and not spill any of the gas that's inside the container that's not got a lid on it, if you were to put that inside a vacuum chamber, what do you think might happen?
I think the gas would go out into the vacuum chamber.
Right. So why does that not happen with Earth in space?
Because gravity is holding the air to the Earth.
And we know that you can't bend space-time to
Hold on.
Right?
Sorry.
Isn't gravity
hold on,
also
hold on.
there in the
I'm
vacuum
just going to
chamber?
ask one question to clarify. So you've got your sulfur hexafluoride, you've got your vacuum chamber. It's got the entire mass of Earth, though, hasn't it? I mean, the vacuum that you can produce on Earth isn't 10 to the minus 17 like the vacuum of space. I mean, you might get down to 10 to the minus 4, but you're not going to get anywhere near the kind of differential that you have with the vacuum of space, Wiggles. But what we do definitely still have is the entire mass of Earth under that sulfur hexafluoride, right? So if, when right next to the most potent gravity that you guys eulogize and have as your religion, why would it be that it would still dissipate into that vacuum that's a much lower Tor value? Why wouldn't gravity still maintain that sulfur hexafluoride, considering it's even more dense and even closer to Earth? That makes no sense.
Well, here's the way to think about it. Like in that example, the regular air keeps the sulfur hexafluoride in the container.
Oh, I
then
see.
in the vacuum of space, the
I
vacuum
see.
keeps
So
the air.
hold on. So what's above the very, very top layer in your pressure gradient? What's above that?
Vacuum of space.
Oh, wow! Something that the pressure would want to dissipate into. So you're still absolutely screwed in your argument then?
No, because we're saying gravity is
No,
holding
because it
the
needs
air
something to press
to the
on,
surface of the
Wiggles.
Earth.
Didn't we just go through this? It needs something to press on, mate.
That's a good
Gas
point, though. So I'll have to think
expands.
about that.
Yeah, it is a good
But
point.
gas
It debunks space.
Dude, even if you would bring your aquarium filled with that gas, put it in a lift onto a very, very high mountain, because the pressure is lower there, this gas in this aquarium is actually going to expand, like all gas does. It's going to actually leak out of the aquarium because it will expand, because it can, because the entire pressure in the area is going to be lower, and it will expand accordingly, just like all gases do.
The stuff in the fish tank would leave the fish tank.
It would
because
expand.
Yes, because
Yes.
because the pressure of the air pushing down on the stuff in the tank would lower when you're producing the vacuum outside the tank. So the stuff would eventually spill over the edges of the fish tank and collect on the floor of the vacuumed vessel because of gravity.
Not necessarily vacuum.
I'm
We're
sorry,
talking about
do
a
I need to
lift
play the
now.
guy from MIT again?
Lower pressure.
No, that's not what would happen. Do I need to play the guy from MIT again?
You're going to show
I have an interesting point, though. Like,
no, let's play the guy from MIT again.
Right? You know what's going to happen spontaneously, right? The gas is going to fill the...
So you know what's going to happen spontaneously, right?
Correct.
The gas is going to fill the available volume. Did you not get the guy from MIT? Let's just play it again.
available volume once it becomes available. And we're going to remove the barrier. The gas is going to fill the available volume. Take a gas, and over here is going to be vacuum, and we're going to remove the barrier. You know what's going to happen spontaneously, right? The gas is going to fill the available volume. Fill the available volume. Fill the available...
So, sulfur hexafluoride, it didn't specify that if it's a particularly heavier than air gas, that it wouldn't fill the available volume, Julian. Didn't you understand what he said?
Yeah, but he's doing a hypothetical...
Yeah, he's talking about a gas in some volume, and he's lecturing at MIT. What do you do for a living, Julian?
Yeah, but he's...
What do you do for a living, Julian? Do you lecture at MIT about entropy? What do you do for a living? I make YouTube videos about retards who think the Earth's a globe. What do you do, Julian? You laugh at YouTubers who make videos about retards like you who think the Earth's a globe. Is that what you do, Julian?
Calm down.
I'm not calm. I'm being lied to, and you are perpetuating it, Julian. You've got nothing but religious faith. You're here as a Jehovah's Witness knocking on our door to tell us about your faith in gravity and your faith in space, and you want to defy what a lecturer at MIT does. What's your job? Are you a lecturer at MIT talking about entropy? Because according to this guy, he doesn't specify that if it's sulfur hexafluoride, it won't instantaneously disperse into a vacuum like you've just asserted, because you're stupid. You think it'll settle at the bottom of the vacuum chamber. Do you still think, Julian, Do you still think it? Do you still think, Julian, like you've asserted, that the sulfur hexafluoride would settle at the bottom of the vacuum chamber? Is that what you think?
If it was on Earth, then yes, it would.
No, it wouldn't. The MIT guys just explained that. Yeah, his example could be demonstrated with sulfur hexafluoride and a vacuum, and it would absolutely disperse into the chamber. You utter moron. He's just explained it to you. You take a gas in some volume, you take a vacuum, and then you remove the barrier. It instantaneously disperses and fills the available volume. He doesn't say, only if I do it on the ISS and we're not subject to Earth's gravity. I think if that was a caveat, the guy from MIT would have said it, Julian.
Well, he doesn't have to explain it because...
Yeah, he doesn't need to say that in his example, certain gases would pool at the bottom of the vacuum because they wouldn't. Julian, listen up. The gases won't pool in the bottom of the vacuum. It's just been explained. They won't do what you've just said, even on Earth. He didn't say this has to be done in space. That's a pretty big caveat. He's just saying you take a gas in a volume and then you remove the barrier and it disperses into the vacuum instantaneously. He doesn't say that it'll pool at the bottom. That's you, a globehead retard, who has said that in the face of obvious objections and obvious defiance of the second law of thermodynamics. So are you now going to concede you're just wrong?
I can watch it.
Are you wrong? Yes, you are,
no,
Julian.
You have a link to the video so I can watch it without making assumptions.
He said
about what the presentation
What
is
more do you
regarding.
need? You're saying the total opposite. You're saying that
What
if
he's
it's sulfur
right there in that
hexafluoride...
10-second clip, it can be anything can be taken out of context.
There's no context here.
Could have said
This is
15
entropy.
minutes ago that any demonstrations I'm going to make here are on the assumption that we're in a universe that doesn't have any external forces affecting on these examples I'm showing on these blackboards.
Doesn't give that caveat, globehead religitard.
Well, actually, the way
He
I
does
think the way
not
to think
give
about
that
this is
caveat.
that gas is like a bunch of tiny little baseballs.
He's not
like a gas
giving-
is made up of tiny gas molecules,
Bye-bye,
which are like little
Wiggles.
tiny
Off
baseballs.
you
So like you
go.
drop it.
Shut your mouth. He's not giving that caveat, Julian. That's not a caveat he explains. He's not defining
Not in that
this
clip that you've
out
shown
in
there, no,
space.
because you've just cherry picked the quote.
Sorry, I haven't cherry picked anything. It's an MIT
well,
lecture.
give me a link to
There is
the
a
entire
link to
presentation. I'll
the
watch
lecture
it and
in the
I'll pass it
video.
on.
You're welcome to go and watch it. We don't know what you do for a living, but this guy's an MIT lecturer, and he's saying it quite specifically without any caveats about it needing to be in space to do this. He's saying you just do it. He's not saying if on Earth and using hexafluoride gas. Yeah, he's not saying that. You're saying that because you're stupid. You don't get it.
What's the title of the video? Insulting me doesn't make the evidence any different or the argument any different. Well, he is. He's calling me names, but what's the name of the video?
He's not.
Who
He's
cares?
judging your ability.
Who cares?
Yeah,
This
he's
is
judging
fact.
your ability, yeah.
I don't want you to go away and
Yeah.
study anything. Your assertion is that the hexafluoride would pool at the bottom of the vacuum. That's wrong, Julian. And I want you to concede it. I don't mind keeping the show open. Until you do, you are wrong.
No.
Oh,
Not
just a
conceding
hand wave
that.
dismissal in the face of an MIT professor saying you're wrong. What an arrogant piece of shit. You are, globehead zealot. So you're so religiously bound to your belief that you will defy what an MIT professor says. What do you do for a living, Julian?
I never take anything as written. I listened to.
Oh,
the
really? What
evidence
about your
and made
religious faith in gravity? You take that as written. You take gravity as read,
Well,
don't you?
see,
You take the
I like to
vacuum.
see
What a
the
liar!
research.
Don't lie to me. You take the vacuum of space as read, and you take gravity as read. What the hell are you babbling about? You absolutely take this shit as read.
He's right, Nate. Dude.
Excuse me, you do take gravity as read. Why the hell would you just lie to us? Don't laugh at me, you religitard. You're a zealot. You're a Jehovah's Witness asserting your religious belief
I don't
in this
think
crap.
gravity is said because I can just pick something up on my desk and go like that, and it drops.
But yeah,
I can
because
do
of
the
its
same-
relative density.
I can do the same thing in a sealed room with no.
So what?
An increased
Relative
pressure
density,
and
man.
lower air pressure, and the thing density's related to gravity anyway, so I don't know why you keep bringing density up. Density
It's not related to gravity at all. It contrasts against it. If it was related to it, then basically we would never ever be able to prove this thing that you called gravity. But it's not related to it. It's independent of it.
Density is we had this discussion the other night, didn't we?
Yeah, we did, and we didn't conclude it properly.
It's like density is a measurement that compares the amount of matter of an object to its volume. Yeah,
oh, really? Are you sure? Isn't there a conversation about moles here, Nathan?
Right. Given the definition of a mole.
Yeah, matter has mass. Mass is affected by gravity. Ergo, density is affected by gravity.
It's affected by the thing you're trying to prove. So we're just going to beg the question now.
No, I'm not begging the question. Do you have a link?
You're trying to prove gravity, and now you're saying that gravity affects it. So you are assuming it in your definition. It's already there. You've just asserted it. You're trying to prove it, and you've just included it.
Density is a measurement.
You've just included it in your definition. You are absolutely begging the question, and you're starting to wind me up. You've just assumed it in your description, haven't you? The word gravity was there, correct?
Say again?
You've assumed it in your description.
No, matter is a substance of which all material is made. This means objects have mass. Look up the definition of mass.
Yeah, let's do that.
You do it. You're defining this, Julian.
Mm-hmm.
What's mass, Julian?
So how come mass changes when...
Oh, so you're going to ask us a question?
You're
going to define your terms, Julian. Your religious belief that you've asserted throughout the show, having said that you don't just take things as read.
Pardon, sorry?
Yeah, you're going to back your assertions and qualify your terms that you're using for your religious faith. You've just told us that you don't take things as read.
No, I do my own research and then I come to my own conclusions.
Right, so let's continue. Mass is what exactly?
Can I just have the name of that video so I can watch that
presentation? Right.
God, Julian.
I asked you like 5 minutes ago, but you went off
check it out on my channel. The name of it was on screen for you. Can you not read? It was on screen.
No, I was paying attention to the video.
Oh, really? You weren't paying attention? What a shock.
Has anybody got a link to it, or is he just going to keep insulting me?
The link's not a problem, dude. Somebody get him a link. However, we still have the problem that you don't want to concede to, which is that you like to research your own stuff and come to your own conclusions.
Yeah.
And then in the same breath, you say that you don't take things on face value, but you do accept gravity, right?
I believe what I see, but I don't believe that density is the thing that causes these things to drop.
But you can't prove that there's an extra force.
Relative density.
Oh, it's relative density, is it?
Yes. I'm more dense than the air I am in. Relative to the air that we're in, I am more dense than the air. Relative density.
Relative density, right. So if you have a ball that weighs 1 kilo and you put it in a swimming pool, it drops to the bottom of the swimming pool. But if you have a ball with a hollow inside of it that's still 1 kilo, but has a bigger surface area, it can rise up. So
depends on the medium it's in, dude.
Oh, okay. It depends on the medium as well. Right.
Yeah, relative density. That's our point.
What's the density value of your ball? 1? Is it 1 kilogram per meter cubed?
It weighs 1 kilo.
Right. Is it 1 kilogram per meter squared? Because water's 1 kilogram per meter cubed. Sorry.
Mm-hmm.
So if they're both the same, it'll sit in a state of neutral buoyancy, which is where the density of one is equal to the density of the other, and there's no force required. I know you're going to tell me it's a net force, but nothing's moving. But we can tell by the numbers. If you've got the relative density of one that's greater than the other, we know what's going to happen.
Mm-hmm.
Well, that's a bit of a problem because you're going to claim that there's a force there, but we can explain it completely by density and relative density. But you dismissed that before when you said that you couldn't explain everything with relative density.
as I leave these guys to argue the toss about relative density, I'm going to say first and foremost a huge, massive, enormous thank you to all of the live audience for tuning in and hopefully sharing this debate. If you hated the show, then smash that dislike button, but then smash it again. But if you like the show, maybe consider sharing it with a friend or subscribing if you've not done so already. Also, a massive thank you to all of the debating panel for making this debate possible. If you missed the first show, it will replay round about now over on my second channel together with the pre-show. And later on this evening, 4 AM UK time or 0400 GMT, the continuation of this debate will replay again on my second channel, Nathan Oakley. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!